Okay, here are a couple more examples from page 36 of your notes. So codeine, an ingredient in some migraine pills, has a Kb of 1.73 times 10 to the minus 6. Calculate the pH of a 0.020 mole per liter codeine solution. Okay, so for this one, we don't know what the formula is for codeine. We aren't going to worry about that. We're just going to put it's a base. Okay, a weak base. It's going to be added to water. Okay, it's going to produce a conjugate acid. So I guess this would be B minus, we'll say. And that's going to produce OH minus. Okay, so even though we don't know what codeine is, we'll just put that. Okay, we know that, again, we'll start with our ice table. Okay, and we know the concentration here, 0.20 moles per liter. Okay, let's start off. We know that both of these are 0, so these will both be plus x. So they're both equal to x. And then this is going to be minus x, but first we'll check rule of 1000. Okay, so 0.20 divided by 1.73 times 10 to the minus 6. Okay, we got like 11,560, so that's greater than 1,000. So this doesn't, there is no change, 0.020 will be there. Okay, so now we can put in our Kb formula. We got our conjugate acid concentration times concentration of hydroxide divided by our concentration of our base. Okay, so now we can find our we have our Kb, so we put that number in, 1.73 times 10 to the minus 6 is equal to x squared over 0.020. So we'll rearrange. So x is going to equal square root of 1.73 times 10 to the minus 6 times 0.20. I'm just going to put those numbers in. Then you got concentration of x, which is equal to my concentration of my hydroxide is 1.86 times 10 to the negative 4. Okay, now I can find my POH is going to be negative log of this concentration, so 1.86 times 10 to the minus 4. So my POH is equal to 3 and for significant digits of 2, so 3.73, and then my pH will equal 14 minus 3.73, so pH will equal 10.27. Okay, and that's my final answer. That's what I'm looking for, the pH of this solution. Okay, and so again, like whenever you're looking for pH or POH, you have to have either the concentration of a hydronium or hydroxide, and from there you can find. Okay, so the next one, what is the pH of a 0.18 mole per liter cyanide solution? So cyanide, Cn minus, we're going to add it to water, and it's going to produce hydrogen cyanide or hydrocyanic acid plus hydroxide. Okay, put in our ice table. Okay, this is 0.18 or 18. This doesn't matter. This will start at 0. It's going to be plus x, and they're both going to be x. Okay, for this one, okay, it doesn't give me the Kb, but I can solve the Kb because the Ka is equal to, so again, I look up the Ka for my conjugate acid, and the Ka for hydrocyanic acid is 6.2 times 10 to the minus 10. Okay, to find a Kb, I just go my Kw divided by Ka, so 1.0 times 10 to the minus 14 divided by 6.2 times 10 to the minus 10. So 1.61, or actually, yeah, 1.6 times 10 to the minus 5. Okay, now I can use that to find my rule of 1,000, so 0.18 divided by 1.6 times 10 to the minus 5. It's greater than 1,000, so I can leave this as 0.18. And now really I'm doing the exact same thing I did here. Okay, I'm not even going to write this out. I'll just write out, okay, like put my numbers in. So Kb is equal to 1.6 times 10 to the minus 5 divided by, or sorry, that's Kb. So 1.6 times 10 to the minus 5 is equal to x squared over 0.18. Okay, and pen ran out of ink, so we got a pencil now. So, but x is going to equal the square root of 1.6 times 10 to the minus 5 times 0.18. Okay, so x equals 0.0017 moles per liter. So again, that's the concentration of hydroxide. So now that we have that, we can use POH equals negative log of our concentration of hydroxide, so 0.0017. So our POH is equal to 2.77, and so our pH would be 14 minus this number, so 11.23. That would be our answer. You predict the pH of a 0.5 mole per liter solution of boric acid. Its Ka is 5.8 times 10 to the minus 10. Okay, so in this case, we have an acid. So we're going to start with that. So H3BO3 plus water. It's producing H2BO3 minus plus H3O plus. Okay, now again, ice table. Okay, the solution, this is 0.50. This doesn't matter. These are both 0 plus x plus x. These are going to both be equal to x. And then we know the Ka, so we can do 0.50 divided by our Ka. And see if it's greater than 1,000. And it is. It's way bigger than 1,000. So this change won't matter. 0.50. Okay. Put our numbers. So now we have our Ka already. So I guess we'll write out the formula. So Ka equals concentration of our conjugate base times hydronium divided by our boric acid concentration. Okay, put our numbers in. So we got our 5.8, 5.8 times 10 to the negative 10 is equal to x squared over 0.50. Okay, so x will equal square root 0.50 times 5.8 times 10 to the negative 10. Okay, so x is equal to 2.9 times 10 to the negative 10. So that is equal to our hydronium concentration. Okay, and pH is equal to the negative log of our hydronium concentration. So we put that in. So our pH is equal to 9.54, which doesn't look right. So let me check this one out. Maybe it's asking for something else. Because like if we know it's an acid, it should have a pH of less than 7. And so just I guess stay tuned for that. I'll look it over and let you know what happened. I think there's just an error in the question. It should ask for what is the pH of dihydrogen borate. Okay, and then this would be its conjugate acid in its case. So you'd use this to find a Kb and go on. But the way this question's worded, okay, really, like this is the correct answer, even though it doesn't really work for what we're talking about. Okay, so really, I wouldn't worry about this question. If you do get like any of those on your assignment that just don't make sense, just let me know. And again, you can always check the answer key and just see how I did it. Last question. So the pH of a 0.15 mole per liter solution of ascorbate or the ascorbate ion is 8.65. Calculate the Kb of the ascorbate ion. So same thing, write out the formula. This is my equation, ice table. These will both be x, or actually they aren't going to be x. We're going to use this to solve for x right now. So we have the pH is equal to 8.65, okay, which means that the pOH is equal to 14 minus 8.65, 5. Okay, and then we'll use the concentration of hydroxide is equal to 10 to the negative pOH, 5.35. And so our concentration of hydroxide is equal to 4.5 times 10 to the negative 6. And so then we can, so that we know that both of these are this number. And then this is going to be minus x. So if we go 0.15 minus the 4.5 times 10 to the minus 6, oops, you get 0.1. But so this doesn't change. It's such a small number that it doesn't change this number. Okay, now we put that into our Kb formula. So we got 4.5 times 10 to the minus 6 squared divided by 0.15. And our Kb is equal to, for significant digits, we have 2 and 2. So 1.3 times 10 to the minus 10 is our Kb.